So here is another question on properties of electromagnetic waves. So it is given that calculate the peak values of electric and magnetic fields produced by the radiation coming from a 100-watt bulb, that is the rating, at a distance of 3 meters. Assume that the efficiency of the bulb is 2.5% and it is a point source. So here it is given that we have a bulb, okay, that is a bulb and it is 100 watts and it is a point source, so it emits light in all directions, okay, outwards like this, straight this direction, like that, like this. So we have to find the the peak values from this radiation at a distance of 3 meters. So here we will imagine a radius of 3 meters from the center, imagining the bulb to be at the center. So we'll imagine a 3-meter radius. So here there will be kind of an imaginary sphere, okay, imaginary sphere of radius 3 meters. So we have to find the surface area of the sphere. So it will be area is equal to 4 pi r square with radius 3. So it is 4 pi 3 square, which is equal to how much? It is coming around 113 meter square. So this is the area of this imaginary sphere. Now it is given that the power rating of this bulb is 100 watt and it is 2.5% efficiency. So the useful power, okay, the useful power that is equal to how much? Efficiency multiplied with the rated power, 100 watt, okay. And if we want to calculate the useful intensity at this radius is equal to 3 meter, the useful intensity that is equal to useful power by sphere area, okay, the area of the imaginary sphere of radius 3 meter. So that will be equal to 2.5 by 100 to 100, okay, by 113. So it is coming around 0.022 watt per meter square. So this is what? This is the useful intensity. Now we know that for an electromagnetic wave, okay, for an electromagnetic wave, there are two expressions of intensity, okay. The intensity can be expressed in two ways. First, in terms of the electric component or the electric field. So that is equal to 1 by 2 epsilon 0 peak amplitude E0 square into C, speed or velocity of the electromagnetic wave. That is in terms of electric field. Another alternative expression is 1 by 2 B0 square, that is the peak magnetic field, amplitude of the magnetic field, by mu 0, which is the absolute permeability. This is absolute permittivity, epsilon 0. This is absolute permeability multiplied with C. Now we can use any of these two equations to determine the value of either the peak electric field or the peak magnetic field. Let us say we go by this expression. So 0 point, okay, let us get the expression of E0. So that implies E0 square is equal to 2I by epsilon 0 C. That implies E0 is equal to root over of 2I by epsilon 0 C. Okay, so here we'll substitute the values. 2 into 0.022 by 8.85 into 10 to the power minus 12 into 3 into 10 to the power 8 root over. So that is equal to how much? It is coming 4.08 volt per meter. This is the peak value of electric field. Now we can determine the peak value of magnetic field using the simple relationship, which is E0, the ratio of the electric field and magnetic field, the peak values or amplitudes, that is equal to C. That implies B0 is equal to E0 by C, equal to 4.08 by 3 into 10 to the power 8. So it is coming around it is coming around 1.36 into 10 to the power minus 8 Tesla. So this is the value of electric field, this is the value of the magnetic field amplitude. Alternatively, you could have done this. Okay, here you could have used this expression to determine the value of B0 as B0 is equal to root over of 2 mu 0 I by C. You would have got the same result, which is equal to 1.36 to 10 to the power minus 8 Tesla, and then you could have used this relationship to get E0 is equal to B0 into C. You would have got 4.08 volt per meter. So anyway you could have done it, you would have got the same result. Okay.